right, it's the middle of the day, and what I'd like to do right now is introduce section 11.3, Secants and Tangents. It's actually one of my favorite sections in the book, and hopefully you'll like it also. The words secant and tangents you're going to find in trigonometry. Tangent we've already introduced, but for this section you'll find that it's something different. It's used differently in this section. So what a secant is basically if I take a line and I intersect a circle at 2 points, that would be called a secant. A tangent is when I take a line and I intersect a circle at exactly 1 point. And that's going to be a tangent. And what we're going to find is that if I draw a radius to that point where it's tangent, it's going to form a right angle. It's going to be perpendicular to that. And also, what we're going to find is that from an external point, if I pick a point out here and I draw two tangents, here's one tangent, here's another tangent, and I connect two radii to where it's tangent, it's going to be right angles here, and I connect from that external point to the center of the circle, a line segment. Well, you can see there's two triangles here. The radii are congruent to each other. This segment in the middle here is reflexive. You have right angles, so that means that these two triangles here and here are congruent to each other by RHL, which means that these two segments are congruent to each other by CP/CTC. So those two tangent segments drawn to a circle from an external point, that's my external point right there, then those segments are congruent to each other. And that's something that we're going to need as we go into the first type of problem that we're going to talk about. That's called a walk-around. I'm going to do a couple of these walk-around problems. First one here is a circle that's tangent to each side of a quadrilateral. So it's tangent meaning it hits exactly 1 point on these along the circle there. And I'm given that this segment is 20. I'm given this segment is 11. This segment's 14, and I want to know what that segment right there is. So it gives you a clue, tells you, okay, let's make this x. And then you hopefully you can see that, well, if this is x, then this has to be, from here to here, has to be x also, because from an external point, two tangents drawn to a circle are congruent to each other. And that means that this segment is going to be, well, this is 20, so it's going to be 20 minus x. And that means that that segment is also 20 minus x. And that means that this segment, since this one is also 20 minus x, the green segment is going to be 11. And here's where you got to be careful. Make sure that when you do this, you put the 20 minus x in parentheses. That's where kids mess that up. And that means that if I simplify this, I get x minus 9. So that means that this is also going to be x minus 9 right there. And that means that this guy right here, go in there. This side is 14, so it's going to be 14 minus x minus 9. Distribute the minus sign here. So I'm going to get, what am I going to get here? I'm going to get 23 minus x. So that's going to be this guy also, 23 minus x. That's what these two guys are. So got all the way, I walked all the way around. That's the name, walk around. And I'm now asking, what is that length? Well, I know that that length is, that whole side is going to be x plus 23 minus x. Huh, the x's drop out. The answer is 23. Now, one little four level aside, and that is that if you look at this, if I just focus on this side right here and this side right here, can you see that you're going to get, I color code these, you're going to get one red segment plus one blue segment plus one green segment plus one purple segment. That's going to be the two highlighted portions here. And if I look at the other two highlighted portions right here and here in orange, I get exactly the same thing. I get a red, I get a blue, I get a green, I get a purple. And that's always going to be the case. So that means that, if you think about it, that means that the two sides, these two sides in the yellow have to add up to, have to be equal to the two sides in the orange there. Okay, and that's always going to be the case with a four-sided figure tangent to a circle on the inside. Okay, and one thing you could have gotten from that, I guess, just taking a step back, I go back all the way back and I erase everything. And I start with the given information here. What that means is that if this side is 20 and this side is 11 and this side is 14 and this side we'll call it x, well 20 plus 14 is 34, 11 plus x has to be the same thing, 34, so that's got to be 23, which was the answer we found originally. I'm going to skip that next one. I'm going to jump to this guy. So problem number 3 here, I'm going to flip the diagram a little bit. And so sometimes you'll see walk-arounds like this, where the circles are all tangent to each other. This side is 8, this side is 13, this side is 11. And I don't know what any of the radii on the inside are equal to. And so what I'm going to end up doing here is I'm going to just pick one of the radii to be my x. So let's go ahead and do that. Let's just say that this will be x, and then let's start walking around. So if that's x, then well, actually let's start with this guy as my x. Then this is going to be x also. This one right here will be 8 minus x as well, this guy right there. And that means that this guy is going to be 11 minus, in parentheses again, 8 minus x. And so this will end up being x plus 3, and that's going to be x plus 3 also. And then I think I'm done. Okay, so that means that this side right here, which we know is 13, 13 is equal to x plus 3, or 2x equals, subtract 3 from both sides, I get 10, so x is equal to 5. And then basically I can plug in 5 for the radius right there, and plug in 5 to find the radius right there, and so on and so forth. Just get all my radii. I think it's going to be 3, 5, and 8 are my 3 different radii. Okay, so that's the first type of problem. They're called walkarounds. The second type of problem is called a common tangent procedure problem. And so there's a procedure for this. And so what you're going to end up with is diagrams that look like this. You're going to have 2 circles. And what you want to do is you want to draw these circles separated from each other. And you definitely want to draw them different sizes to each other. And change the thickness here. Okay. So the first step here, it says that it's given that centers of 2 circles of radii 10 and 5 are 13 centimeters apart. Right here you can see that the way I drew this is probably not correct, but it's going to work out better if I draw it so the circles are separated from each other, because the radii are 5 and 10, and then this distance from the centers are 13. It doesn't quite make sense the way that it's drawn here. But I'm going to go ahead and draw it like this and do the problem, because it does help to kind of see this a little bit better. So the first step in my procedure is I'm not going to actually write out the procedure, but I'm going to say it out loud. Step 1 is to draw a segment joining the centers. Yeah, there's my segment joining the centers. Second step is I'm going to draw radii. Oh, actually, I'm trying to find the length of sorry about this. I'm trying to find the length of a common external tangent. So the common external tangent is going to look like, it's going to be the tangent line that's in common between the two, and it's going to be on the outside. It's going to be on the external. Okay, so it's going to look something like that. That's the length of the common external tangent, and I'm trying to find the length from this point to this point right there. Okay, and I know that from those 2 points, my step 2 here is I'm going to draw a radius from these 2 points to the center, and it's going to be drawn perpendicular right there and there, because the tangent connecting to the radius of a circle is always going to be perpendicular. And then my step 3 will be through the center of the smaller circle. So here's the smaller circle. I'm going to draw a line segment that is parallel to this external tangent. So it's going to be like this. Okay, so these 2 lines are parallel to each other. That's going to be my 3rd step. My 4th step is I'm going to notice that I have a rectangle and a right triangle. So here's my rectangle right here. Oops, need a different better color here. Here's my rectangle. And hopefully folks can see that my right triangle is going to be right in here. Because it's a rectangle, this angle is a right angle here. This also has to be a right angle right there. The mistake a lot of students make is that they make the right angle at the center there. The right angle will never be at the center there. Okay, it's never going to be there when you draw this out. And so I'm going to fill in some information here. The radius is PIR 5. This is my last step, 5. This radius is 10. But I have a rectangle, so that means that this side is 5, which means that this is also by subtraction. 10 minus 5 is 5. And I know that this blue line, the original from center to center, is 13. And so I got a 5 green segment here, 13. So that means that this green segment has to be 12. And it's a rectangle, so this is 12. And guess what? I'm done. That's the common external tangent. Let's try one more problem. Let's do this problem down here, number 3. We'll do a common internal tangent problem. Common internal tangent. So I'm going to go ahead and draw this again. I'm going to draw it so that, again, my two circles are, well, that looks more like a heart. Sorry about that. My two circles are clearly different sized. Here's my two centers. Common internal tangent is what we're looking for. And the internal tangent is going to be drawn like this. It's going to be the tangent line that goes in between the two circles. So it's an internal tangent. First step, I'm going to follow the exact same procedure I followed for the previous problem. I'm going to connect the two centers of the circles. Step 2, I'm going to go ahead and draw in radii that are going to be perpendicular to the common internal tangent. Step 3, through the center of the smaller circle, I'm going to draw a line that's parallel to the internal tangent. And then this is the one step you have to kind of add in for these internal tangent problems. I'm just going to go ahead and connect this here. And hopefully you can see that. What that does, it's I am creating a rectangle, and I am creating a right triangle right there. Okay, so now let's go ahead and fill in some information here. I know that my radii are 3 and 5. This has to be 3. This is going to be 5. This is also going to be 3 because it's a rectangle. And it says that the centers are 10 units apart, so this is 10. And so this whole side's got to be 8. And I know it's a 6, 8, 10 triangle, right triangle, using my triple information. So I know this is 6, which means that the blue line right there, because it's a rectangle, is also going to be 6. And I'm done. That's the length of the common internal tangent. Hopefully you liked those two types of problems. I find them to be kind of interesting and sort of fun, which is what this is about, right? Enjoyment and challenge. Okay. That's all I have. Take care.